there are going to be more students to enter this session. Okay, let us begin, but at least I need to know your background. Okay, dear student, just type in the chat box from where you are. I mean, your course, the current postgraduate level you are taking, and either you are doing master or PhD, and from which kuliah you are from. For example, just gonna give I will give you the example. Okay, your short name, all right? So this is kind of roof so that I could see your background a little bit. Okay, perhaps everyone just shout in the box so that I know your short name, currently the level of your study, and which kuliah you are from. Okay, you can share in the chat box. Okay. All right. I wish to see more of you. All right. Okay, we have Amani, Fatima, Amira, Inaya, Badria, Shawun, Nadia, Hirma, Ahmad, Fakrul, Mahyudin, Adhfar, Laboni. Okay, all right. May I know how many of you doing human-related research and laboratory research? Okay, it's okay. Just blast your name, your level, and your kuliah, your faculty. And my second questions, just to get to know your background. Okay, if you're doing a social science research, so you just put over here social science or medical science. Um, if you're doing like a laboratory study, you put BMS. So I know that if you're doing like laboratory, you are actually doing some things like in vitro, in vivo, because my angle is a social sciences. This session is more like on social sciences rather than on those laboratory sciences. But it's a good thing you could listen to this session because later on when you complete your study, this knowledge will be applicable to you as well. Okay, I can see those doing BMS, nutrition science, all right, rehabilitation. So I believe that when you did rehab, of course, some part of it is like a social sciences method in doing your study later on. Okay. All right. So I would say that the background of you at the moment is a mixture between those who doing the laboratory sciences types of study and those who did on the social sciences. No, don't worry. I will say that this knowledge, no matter how, is still applicable to you and will be benefit you, inshallah. Okay, let me share my screen. Okay, can you see my slide now? Okay, we will start with sampling design first. This is very important topic because you need to know what is the aim of your study, what is the objective of your study. Then this objective normally will align with your research design. And once you have decided the research design, it is important for you to choose either the probability technique or the non-probability technique. So but this is where you can refer the extrapolation, the inference, or the generalizability, because sampling will influence whether you can generalize your findings, your sample, because we are not able to collect the whole population in Malaysia, for example. We only take subset of it. So choosing sampling design is very important because this will determine whether you can extrapolate or making an inference, or you can generalize your findings or not later on. All right. Okay, so this is something that I wish to acknowledge. Some parts of my note is actually taking from this book. Oh, I'm trying to hide this floating panel. Okay, all right. And then I have a book written by myself. Okay, this is the book that I've been writing with my colleagues over here in Kuliah of Nursing. All right, next. Okay, this will be our objective for today. So we wish to discuss on the basic sampling terminology and types of sampling design to describe the methods for selecting appropriate sampling design. So what is population? So therefore, I wish to introduce you the concepts of population and sample. Normally, we are not going to do study for whole population in Malaysia, as I mentioned just now, because definitely as a students, you have some limitation. You are not funded by research grant that will actually restrict your capacity to conduct study a larger population. So normally, we only do sampling. Therefore, we need to choose a proper sampling method, and later on, you need to calculate your sample size so that this sample size is actually could make an inference to the population. Okay, so what is sample? Sample is a subset of the population. So I hope you can differentiate now what is actually the types of sampling design. We have the probability and non-probability. Okay, probability usually you can have a better inference. Okay, in probability sampling, there is an equal chance for a respondent to be selected as sample, and this could represent the population, as I mentioned just now. If you choose the correct sampling method, the probability, you can make an inference. So sometimes is it also in probability sampling, it is also known as random sampling. So random sampling is actually referring the equal chance to be selected as sample. So in non-probability, because we have like a smaller sample size, therefore, when you got the results later on, the findings could actually represent the particular samples only. But most of the time, convenience sampling in the non-probability sampling is actually very economic and easy to perform. And for a master level students, you guys commonly apply this method, the non-probability. But bear in mind, when you have the results later on, your findings, it could only generalize to your current sample. So you cannot be so ambitious saying that your study actually reflecting the whole sample in Malaysia. For example, you collect data only at among stroke patients in SASMAC during rehabilitations. Okay, once you've received the result, for example, you only conveniently select 30 patients from your rehabilitation sessions to be part of your intervention, for example, and the findings only could extrapolate or could be generalized among the stroke patients attending the rehabilitation session at SASMAC, but you cannot claim the findings is referring to the stroke patients at Malaysia setting. So careful when you are choosing the non-probability method. Okay. So this is very nice reading materials. I will share later on the articles, or by right you can just click on the Google and try to search on this title. Okay, these articles is nice. It shows how the authors debates on different types of sampling technique. Okay, so as I mentioned earlier, we have the probability technique and the non-probability technique. So in probability technique, we have the simple random sampling, we have systematic sampling, we have stratified sampling, cluster sampling, multi-stage sampling. Okay, normally in simple random sampling, it's easy for you to use I just say throughout my experience as a researcher. You have the computer, you can ask the computer to generate the random number. In systematic sampling, it will be easier if you have the list name, whereby you can calculate on the K percentage according to the list name. In stratified sampling, normally if you wish to stratify according to certain criteria, whether you wish to stratify according to race, whether you wish to stratify according to certain age group or gender basis or education level, then you may apply the stratified sampling. Okay, for cluster sampling, normally your cluster and multi-stage, normally if you run a largest type of study involve many setting. For example, you collect data at the community side among I would say that the general population, most likely cluster sampling and multi-stage sampling will be adopted by all of you. Okay, so in Stratify, you can see there are proportionate, certain percentage is allocated to calculate how many samples for each strata, and there is disproportionate as well. Okay, so when we talk about non-probability sampling, normally it is classified as convenience sampling, quota sampling, judgmental sampling, and snowballing. Okay, most of the time, for quantitative sampling, we apply convenience sampling or purposive sampling. I forgot to add one more. I can see the trends evolving. You know, there are so many definition terms of new types of sampling method. Therefore, I read journals so that I could keep abreast what is actually the recent trends in these different types of terminology. But when I go through and read the journals, it's actually sometimes referring to the same things used before. So don't get shocked, particularly in the era of computer AI. So there are few new terms to me. I will be sharing with you guys what are the new terms that I found when I updating my slide. So that is actually similar things but only a different terms. Okay. So we have like few other terminology. Purposive is something you get to use. Later on in the slide, I will show you what is actually just come to my new knowledge. I think maybe some of you are already aware. Okay. Okay, so sometimes why you choose certain samplings also were affected by variables, but most of the time we choose our sampling method depends on research design most likely. So this is actually what is referring to a probability sampling, whereby as I mentioned earlier, it's unlikely that a researcher has the capability or entire access to study the whole population. This is due to the limitation. You are collecting data by yourself. You don't have any helper. If you're undergrad, it's a different thing. Perhaps your supervisor or the principal investigator could help you in arranging the GRA. But if you're not under certain grant, you are under your own sponsorship. Most of the time, you are the one who doing the data collection. So you have this restriction of manpower, financial assistance, time constraint. Remember, PhD is not some things that you have to think so ambitiously. The main aim is you need to graduate on time. If you're doing master, you should graduate by second year of your study. If you're doing PhD, hopefully by third year, you could completed and submitted your thesis. That is more important. Okay, therefore, if you can't afford to study the whole population, make sure you correctly calculate the required sample size so that at least you can make an inference to the population. So normally for population, we call it as parameter. If you're actually just study the subsets of the population or the sample, then we call it statistics. So we measure the sample using statistics in order to draw inference about the population and its parameter. So choosing sampling technique also has some things to do with inference to the population. Therefore, when you are adopting probability sampling, there is a higher chance that you could infer your results to the overall population. But if you're choosing the non-probability technique, your findings could only generalize to your current study population alone. Okay? Alright, so this is about probability sampling. So we go with simple random sampling first. What is simple random sampling? So it's applied when the target population is homogeneous. So homogeneous meaning that you're only study about one type of population. For example, only among diabetes patients, only among patients with hypertension, only among patients having cachexia or chronic energy deficiency. So most of the time you can apply the simple random sampling. However, if the sampling frame is difficult to obtain, then this method is not applicable. Okay, perhaps you need for a rare disease, for example. So you may choose purposive instead of simple random sampling. Bear in mind, not all sampling must use probability technique due to this restriction. For example, you are about to study the impact of OCP among pregnant mother that having stroke. It's very hard for you to get a pregnant mother who actually getting stroke during their pregnancy due to OCP induced. So this kind of this kind of population is not reachable easily. Then you need to apply the non-probability method. Okay, so what is systematic sampling? So in systematic sampling, it is applied when the target population is homogeneous as well, meaning that only one types of population and you will be selected it based on the interval K. So how are you going to get the K? So you need to know what is the size of the population. And after you calculate the sample size, you need what is the required sample size, then you divided it according to the sample size required, and you got the 20th, the sequence. So it is very important for you in systematic sampling if you could get the list name beforehand so that you can get the list name either manually or you can get the access to the database. So if you could have these kinds of accessibility, then the probability, the chance for you to apply this method would be easy. Okay. So this is how are you going, how the 20th, every 20th would be taken to become your sample later on, meaning that patients who falls under number 5, number 25, number 45, number 65, 85, 105 will be selected to become your participants. I mean, this is actually referring to the list name. Okay, most of the time, systematic sampling is easier to be adopted if you have the access to it, like the list name. All right. So stratified, as I mentioned earlier, normally if your intention is actually to stratify the participants according to certain characteristics of the socio-demographic background, like their marital status, ethnicity, gender, socioeconomic, etc. So stratified is the most suitable sampling method for your study. Therefore, the nature of the target population will be heterogeneous. So this is actually among the best, among accurate, because you make sure all your study involve all the strata. Okay, so this is the example. A researcher decided to obtain 10% of sample from overall 500 stroke patients population. Okay, this is how you stratify according to the race. In this case, I give you the example of according to the race. So you have like 500 parameter of the populations, meaning this is the N big showing the informations on parameter. Okay, the small n is actually referring to the sample size. So be careful when you are writing the N capital or the N small. Okay, so from your database, you got the information that there are 200 participants are Malay, 150 of the participants are Chinese, hundreds of them are Indians, while others like Sabahan, Sarawakian, orang asli, there are 50 of them. So you stratify accordingly. So 200 from 500, you times with 100, you need 10%, sorry. 200 over 50 times with 10%. So you need 20 for Malay, Chinese 15, Indian 10, others 5, and altogether you will be obtaining 50. So this is what we call as stratified. All right. So similarly, like stratified, so sometimes you might apply cluster sampling. If you're lucky enough to be one of the research output in a larger grant, a national grant by your supervisor might be a tip-top researcher who has a multinational grant or large projects. So you might be the output, the research output. So you have the chance perhaps to apply this cluster sampling. You might be involved in just one center, but there will be another few other researcher working at a different center, a part of you. So in cluster sampling, similarly, they are heterogeneous. The target populations are heterogeneous. It may involve large geographical area like a multi-center, multi-region, and sampling frame sometimes difficult to obtain. And I can give the information here, the example. Perhaps you're actually looking for patients attended at klinik kesihatan in Kuantan. As we know, in Kuantan, there are a lot of klinik kesihatan. So you wish to see their perceptions, their acceptance on PPV, for example. On Pap smear, for example. Okay, so but you can apply cluster sampling in your study. Okay. I think I skip this video. You can enjoy seeing this video later on. Okay, I will stop, take a break here for a while, 5 minutes before we continue with non-probability sampling. Okay, in brief, could you just type in the chat box what are the types of probability sampling that I've mentioned before? Okay. Everyone, you can just type whatever you can recall. The more you can recall, the better. So what are the type of probability sampling? Okay, feel free to write in the chat box. Okay, good. Right. Recall as much as you can. All right, nice. Okay. It helps you actually to improve your retention. Okay, I wish to see more answer. All right. You can go for 5 minutes break. We start. Keep on answering. Okay. All right. For those who just entered the session, just a revisit back. I hope for those who just came in late, please be punctual next time because this is a new journey for you as a postgraduate student. Time management is very important. Okay. As much as I can come early for this session, I hope you could also come early and on time. All right. So for those who just this is might be something you know before, but it's okay. We are actually refreshing our knowledge over here. So there are two types or two large categories of sampling design, probability and non-probability. We already discussed the first part of it, the probability technique. We have the simple random sampling, systematic sampling, stratified sampling, cluster sampling, and multi-stage sampling. And we are about going to discuss this later on because we already finished here for those who just came in late. So we'll be discussing after this on convenience sampling, quota sampling, judgmental sampling, and snowballing, and a few more different terms of new terms in the sampling. Okay, I wish that for those who just came in, this is nice article. I'll be showing another nice articles. This is by one of the medical doctors and the other articles from a group of nurses. I would say that these kinds of reading, get a habit of reading journals each day. So my character is that every morning before I came to work, I will read one article at least. Okay, so I'll skip this. You can read my notes later on for those who came in late. Okay, now we're going to go for non-probability samplings. As I mentioned before, we have convenience sampling. So why we choose convenience sampling? Because our aim, we have a certain target of audience. This is what we call as captive audience. So respondents are selected because they happen to be at the right time and at the right place during the data collection. So normally, for you, if you think you have a restriction of time, you have a constraints of budget, you're not under certain grant allocation, I would say that convenience sampling is something that is suitable for you at the moment. Okay, so whoever happened to be at the right time when you are doing the data collection, and that will be a sample that you conveniently perform on your targeted participant. So sometimes it's often used in exploratory research to generate ideas on certain phenomena, insights into certain problems. I mean, if you wish to know the basic to develop hypotheses or to pretest a questionnaire or to perform pilot study, then this method is suitable for you. So the issue is that, as I mentioned earlier, when you adopt a non-probability sampling method, you cannot generalize your findings to the overall parameter or the populations other than only to your sample of group. So at the same time, when you adopt this method, the weakness is that it's very difficult for you to determine there is a potential of sampling error because you select people whoever happens to be there when you did your data collection. So sampling error is unlikely to be detected easily. And then there will be a selection bias, definitely, and motivation bias as well. Selection bias comes from the researcher because, as a researcher, you wanted to get data in a very fast manner. So whoever happened, you recruit them. That is actually exposed towards a selection bias. And the other one is a motivation bias for the participants because normally like a questionnaire. Biasa kan jawab questionnaire kan? Betul tak? You all? So biasanya certain people you are very motivated. You tend to respond. But certain people I mean your character is just couldn't be bothered lah tak lah. Kau punya questionnaire bukan pasal dia aku, kau punya pasal lah. Okay? So this is actually um a motivation bias that will jeopardize the data collection as well. But it's okay. That is the nature of non-probability technique. So this is some things the issues will raise when you adopt this method. So normally for convenient sampling, some debate says that it is actually debates, and this is debates. Debates means a different school of thought. Tak semestinya salah kenyataan ni. So there are certain researchers says that this method is not suitable for descriptive study or causal research. But most of the time ramai je yang apply convenient sampling method. Alright. So there are another type, judgmental sampling. Okay, judgmental sampling, the selection is conducted based on the researcher judgment that the sample has the criteria required for the study. So, for example, a researcher selected only the male patients attended to the outpatient department to obtain their views on the effect of smoking on stroke. This is because the researcher believed that male smokes a lot more often than the female patients. So this is an example that I can give to you, but there will be more example later on. Okay, so nama pun judgmental. I mean, the name itself is judgmental, so it depends on you. Therefore, you need to set the criteria. What do you want in your study? You want to see certain habits only that happens among certain population, so then judgmental sampling will be the best one. Okay, in quota sampling, stratified sampling is a non-probability. The technique here, it is actually almost similar to the stratified sampling. Okay, again, there is debate. There is also certain researcher, like I showed the article just now, it is also claimed to be part of convenient sampling. So most of the time, quota sampling is actually performed when it is very hard for you to get certain required number, so and or you require certain percentages for your sampling, so quota sampling will be applicable. Okay, I will explain the example later on based on the real study. So perhaps in this study, the initial baseline is collected conveniently. Then later on only you perform the quota based on certain characteristics and the required number of sample size that you need, which is determined by you. Okay, this is a real study from Campbell, the examples that given by Campbell. So for example, in the study, children with chronic illness, there might be a quota for kinds of chronic illness and for kinds of family. So the research team would specify a minimum for each of the quota. For example, given over here, a minimum of 5 children aged with diabetes, leukemia, arthritis, and for the kind of family, 10 from a nuclear family, 15 from a reconstituted family. So this is already decided by Campbell et al., whereby they need children having this kind of disease, diabetes, leukemia, came from nuclear family and came from the reconstituted family. So initially it begins with the convenience and then they have certain allocated number required. So this is actually called quota sampling. Okay, there is one more, snowballing sampling. Snowballing is actually commonly adopted in qualitative sampling method, qualitative study. So it is applied when the populations and the study is not easy to find. For example, I can give here, perhaps a case of sexual harassment among children with disability. I would say that sexual harassment, something that is common happen, but whether there happens the prevalence of the incidence of sexual harassment and the under the among the kids with disability is difficult to find for certain reasons, like the access to the kids itself because they are disabled. You need to get the guardian to disclose this information, then you might apply snowballing in your study. So normally the sampling frame is actually very small, and how you're going to get this information is actually you're asking one from one respondent, And perhaps you can share the informations that, okay, whether they have colleague, whether they have a family who face the same problem. So for example, I give you a similar example just now, like stroke patients that encountered stroke due to coagulopathy after the use of OCP. Or like I mentioned, kids being disabled and having a sexual harassment issues, or there are certain like you wish to study among mothers who I mean among female with HIV marrying someone having HIV, even though we don't encourage them, but you wish to study further on this issue, so perhaps you can apply this snowballing sampling technique during your research. Okay. I'm not sure whether I should. Ah, okay. This is the article by Campbell. Please go and get this article. Very nice article. All right. So now it comes to purposive sampling. So purposive, the name is purposive itself. So better match of the sample to the aims and objective of the research, thus improving the rigor of the study and trustworthiness of the data and results. The keyword here, the rigor of the study, the trustworthiness. So therefore, most of the time, purposive sampling is actually applied in qualitative. However, okay, again, then this will be a different school of thought. If you are about to study certain rare disease, it is actually applicable to a quantitative research too. Okay, so four aspects that this concept have previously been described. It is strongly associated with the aim of, I mean, the findings could be have certain credibility, transferability, dependability, and conformability. So therefore, this niche is actually referring to a qualitative study types nature. Okay, so what has been raised by Stratton is that this kind of method have bias. So research bias here is that sometimes the researcher might select their own colleague to be the participants. Okay, again, this is actually not recommended. But if you think that it's very hard for you to reach certain population, you have no choice. But this is the things that may raise, according to Stratton, when you adopt purposive sampling method. And there is an issue like non-participant error, like decline from the participants in answering your questionnaire, for example, or to participate in your interview session. So this might also raise an issue of participant error. Okay, okay. You can read further on this article. We'll say that the example, the case study written in this article, giving you some idea. Perhaps it might be suitable with the current, your current situations, on deciding whether you want to apply purposive, whether you want to apply convenience, whether are you going to apply judgmental at this moment. Okay. This one is actually new to me. Maybe I'm not updating my knowledge, but I wish to see hands over here. Perhaps have you heard about voluntary response sampling so far? I wish to see hands. How many of you heard about this term? Voluntary response sampling, because I've just realized yesterday when I was updating my slide. Anyone? Just raise your hand. Just raise love. Have you ever heard about voluntary response sampling so far when up to now? Or you just can write in the chat box if you ever heard. Yes. Okay, bagus. Okay, I nak tengok juga. I rasa macam aku dah ketinggalan zaman ni. Tak tahu ni. Therefore, get a habit of read a journal every day, you know. Sometimes if you never read journals every day, you might be left out. I will say that it's good to have habits of reading, even very brief journals like editorial comments. It helps you to improve your knowledge. Okay, so this is something new to me. Mungkin orang lain tak. I je yang lambat sikit. Okay, so hold on. I'm going to share back my screen. Okay, so there is a new term I just discovered yesterday. Okay, so this is actually how you select possible members of the target populations to be invited in your research. So commonly it is applied online. So nama macam when you look at the terminology voluntary response sampling, it is like either convenient sampling or purposive sampling, right? But it's only refer to those answer the questions via online. So this is some things that I newly discovered yesterday, introduced by Straighten, the terminology as voluntary response sampling. So it is actually prone to self-selection bias because you only approach whoever the participants who are available online only. So therefore, there is the issue of self-selection or researcher bias is here. Okay, sometimes this technique is confused with census research. And for example, can give you some idea. You obtain a list of participants from organization A and you ask them to get involved in your study. So this is actually a voluntary response sampling. The example as given by Stratton. So in a conclusion, what is the difference between probability sampling and non-probability sampling is that in probability sampling, as I mentioned before, it allows you to test the hypothesis. You can estimate the population. You can perform the inference. You may eliminate bias. It has random selections units. However, when we talk about the non-probability, it is more suitable for exploratory research to generate hypothesis as well, or you are about to study sample part of the population parameter. So, or you not able to get large number, as I mentioned, for difficult population you wish to reach, then the non-probability technique is actually recommended for you. And of course, when you apply non-probability, it is actually cheaper, it's easier and quicker to carry out. So this is actually the benefits of the non-probability. However, in research, we always recommend you to adopt the probability technique. Okay. So in conclusion, for this topic, for the sampling technique, you need to know, choose the correct or the appropriate, I would say appropriate, because sometimes there is no best method in the research, there is no perfections. Choose appropriate sampling method based on your research design, get to know your objective, and then consider, this is very important, bear in mind, graduating on time is your ultimate aim. Consider about your time, about the manpower available to assist you during your study, and whether you're support with a big grant or not. Then you may decide which types of sampling method is actually suits you. Of course, the probability technique is highly recommended, but you must know your capacity. Alright, so we have another topic later on. So this is a reference that I've been using in preparing this slide. Okay, so I open questions. Do you have anything you wish to raise in regards to my topic? Feel free to open up your mic, to open up your camera, so I can see the person who is asking me the question. Okay. So how many of you has already, I mean, all of you here are in semester 1, year 1, I suppose. Okay, is snowballing sampling similar to respondent-driven sampling? Okay, what is... Okay, good question, CB Badri. Is snowballing similar to respondent-driven sampling? What is the best sampling for hidden populations such as transgender, LGBT community? Okay, I have to be frank with you, CB. This is also first time I heard about respondent-driven sampling. Can you share with us the articles where you've got the term respondent-driven sampling? It looks like a snowballing. It sounds like a snowballing because respondent driven, meaning that the respondent introduced their friends to the researcher, I believe. Is that what it says? I mean, what the description is it what I'm telling you, is it suitable with respondent driven sampling, CB? If it's yes, then just put it yes there. Because to be frank, I would say as I've been open. If I know or not, I just share with you guys. Yeah. So okay, again, you wish to reach this transgender LGBT community. Yeah, I would say that you can apply snowballing because once they got trust with you, only then they will introduce their friends. Building up trust is very important, particularly when you are doing some things like sensitive issues among the transgender team. So yes, snowballing is the most appropriate, particularly if you're about to ask their lifestyle. It's very sensitive, and as a researcher, whatever you know between you and your participants, you need to keep it confidential. Okay? So it's actually between you and the participants only. All right. Okay. So any more questions you wish to ask about snowball? Okay, one question on snowballing. Anyone? Any more questions? Okay, if there is no more questions, we go for a 10 minutes break. We'll start back at 9:30 a.m. on sample size. Okay, I will share my slides over here so that you can get my slide. All right. Okay, Alhamdulillah, welcome back everyone. We're going to start with our second class, which is on sample size calculation. All right, this will be our second slide for today. Okay, again, bear in mind, I am so sorry. First of all, if these sessions, my slide never even touch on the sample size calculation for those who did study on laboratory, because my expert's angle is actually on social sciences. So I would say that perhaps in the next future, I wish to suggest to CPS, maybe for sample size calculation, there might be another slot for laboratory wise. Mine is on human. I mean, we are sampling on the human for recruitment process. Okay, so this is a suggestion that I wish CPS could take in the future, to take action in the future. Okay, are we guys ready? We come to our second class for today, sample size calculation. So the objective for today's session is to discuss the concept of hypothesis testing in sample size calculation, and for you to apply the concept of hypothesis testing in sample size calculation. Okay, back to our previous session just now, if you still remember, we can't afford to study the whole populations. So most of the time, we only study a sample so that if you apply the probability technique, it could infer back to the population or the parameter. Or at least, if you're applying a non-probability sampling, you can make inference to the current sample that available to your study. Okay, so in order to do so, we need to get certain amount of the required sample. Therefore, we need to calculate sample size so that it is fulfilling our study. Okay, doesn't mean having no fixed sample size calculation is not good. The sample size is actually a part of what we call that rigor, or part of internal validity of our study. But having a sample size calculated properly, it shows that you are achieving the internal validity of your study. All right. So is if you ask me as a lecturer, is it so important to capture the adequate sample size for your study? Yes. My answer will always be yes. So please get a statistician for consultation in the future. You need their advice. You cannot simply wish to do study as what you think, okay, this is adequate for my study. No, the answer will be always get statisticians to consult you on your sample size calculation. You can do the calculation on your own first. However, validate with your statistician, or discuss with your supervisor. If your supervisor is very expert with sample size, don't worry, that is good enough. However, if she or he thinks that you should consult a statistician, please listen to your supervisor. Please listen to supervisor and abide to what his recommend or her recommendation. Alright, it's very important for you to refer to a proper statistician to confirm your sample size calculation. Okay, so there are two methods commonly applied when we calculate sample size. Either we calculate it manually using certain formula according to our research objective. Research RO is research objective, RQ is research questions or research hypothesis. So for qualitative study, there is no requirement for sample size calculation. Who did on qualitative study, no sample size calculation. You need to understand for qualitative, the concept of saturation is ultimate goal. Okay, so it's different. If you're doing some things on quantitative study, you need to determine the appropriate sample size. So the second method is that you can use software to calculate the required sample size. So there are certain software available online. For example, that for like RaoSoft. If you're doing survey, then you can use RaoSoft. We have EpiInfo. We have the PS software. Okay, I will show you accordingly later on. And I will share with you one Excel calculator that is actually developed by Dr. Wan Arifin back in USM. And yeah, she meant for it to be shared as much as possible. He meant for it to be shared. So I will say that after this, I'm going to share with you in at the chat box later on. Okay, so for today's session, I will not cover the ready-made tables, the nomograms, and this is actually beyond the scope of today's session. All right. So this is why you need the reasons why we need sample size calculation to ensure that we obtain adequate number of samples required to estimate a disease or a health condition. So there is estimation, there is hypothesis testing. So estimation is actually referring to the informations on prevalence, informations on incidence, and in regards to hypothesis testing, you're actually testing your hypothesis. You wish to see the relationships between the IV and the DV. So in estimation, researchers need to have acceptable confidence intervals or estimates. So to obtain adequate number of samples required to test a hypothesis, you have to make sure that the power of study is acceptable to detect significant difference within two study groups. Okay, so this is the difference. I think I will show you later on in table that makes the understanding better. Okay, so a part of knowing the requirement of sample size is actually related to your RO, RQ, RH, research design, RD is research design. There are certain things also need to be considered. So you need to know what is your outcome, the nature of your outcomes. Either your outcome is in the form of prevalence or percentages, or either your outcome is a numerical data, is it a ratio data, or the outcome is it in the form of categorical data. You have dichotomous, perhaps. So you need to know these elements as well because you need to consider we need to consider this during the sample size calculation. All right, so the formula will be difference. Okay, for example, in survey research design, commonly you may apply single mean if your interest is to see on knowledge score, for example, or if your interest is to determine the prevalence, perhaps you might use single proportion. So in an observational study, perhaps you wish to see the difference of score between gender. You might comparing the knowledge score between the male and female. So you may use two means, or you may also use two proportion. Okay, so this is actually the different terms. I only touch on this because I will say that this is the basic things that at least you need to know for today. All right. So I give you a simplified versions on how the level of calculating sample size for estimation and for hypothesis testings based on the objectives. So you can see here my first example. You wish to estimate the level of stroke knowledge among stroke patient. So the knowledge is actually score. So you can use single mean formula because why? The outcome is in the form of numerical variable. Okay, my second example. The second objective here, to estimate prevalence of stroke among stroke patient. So you can use single proportion formula because the outcome is in the form of percentages, a categorical variable. So these two examples is actually referring for an estimation. Okay, for example number 3 and 4, to compare the mean of carbohydrate intake among stroke patients admitted to HRPZ2 in intervention and control group. So I am comparing the mean of carbohydrate intake. The mean, when we are talking about mean, normally it's actually the outcome must be in the form of numerical data. So you can use PS software, then you use the t-test formula. We'll go to the example later on. Okay, this one I've taken the example from a journal actually. Okay, to compare the proportions of obesity among male and female athlete. Okay, you can use software as well, but you can use the dichotomous formula. So this is actually referring to the hypothesis testing. Okay, so we go one by one. Alright, so how to estimate the first example or the first objective? We use single formula. So this is the research objective. So this is the research questions and points of consideration. How many stroke patients do we need to estimate the level of stroke knowledge? So what must you consider after while calculating the sample size is that the result should estimate this information. You need to report the mean and 95% CI. So the mean of score at 3 months, for example, and the 95% CI. So how you write, this is also a standard words when you write a samples, the output for a sample size calculation. So we are 95% confident that the mean level of knowledge at 3 months range between one value to another value. You need to state the mean value, and then you need to state the 95% CI as well. All right. So in this case, the example given here, don't worry, this is based on my example. So the range is 8.10, the mean score, to 14.19. It shows an improvement after 3 months. Okay, so the questions will be, how many stroke patients are needed to become the study subjects in order to ensure the result will be acceptable CI. So remember, a large CI, the large gaps of confidence interval is not good. So you see over here, negative 7.40 to negative 4.79 doesn't cross zero, meaning that, and the gap is also not that wide, and this is actually a precise findings. So therefore you need to know the precision. You can be judged with the width of the CI. So once you look at the table or whatever results later on, if the gaps is too wide, then you can see perhaps the sample size very little that cause the difference, the variations. Okay, so this is the formula of the single mean. So how many sample you need to estimate? Commonly for 95% CI, the Z will be 1.96. So the standard deviation you need to perform to get it from you can use your pilot study, and or you can use the finding from previous study, and you need to decide the precision, the delta, the expert guess. Okay, so the sample size calculation. So we assume that I've got the SD from my pilot study is 2.98. The Z value is constant at 1.96. So when the sample size bigger, precision's value getting smaller. So this is more precise. So if the precision value is constant, the SD is changing. The value of size has direct proportion to the value of standard deviation. So this is actually shows when there is increased sample size, there is increased SD, perhaps there is more variation. So you need to decide based on your, again, even though you calculated the sample size, it is also important to consider your resources, the manpower, and the financial support in the end of the day. Okay, this is an example. Okay, because of small sample size here, the result may require 5 samples. But again, you can manipulate this expert's decision. You can increase. So you can ask the opinion from your statistician how to decide on the value over here. Alright, so this is just an example. Okay, so now we go to example number 2. How are you going to use the single proportion? So the example here given is on the prevalence. So prevalence meaning that the outcome is actually in the form of percentages. So when the outcome is in the form of percentages, so you may use the single proportion. So for example, the research objective here, a study is conducted to estimate prevalence of stroke among patients admitted to HRPZ2. This is a real example. I've given the setting. Okay, so what is the prevalence of stroke? So what should be considered here is that how many patients that you need to estimate on the prevalence. So when we talk about prevalence, since the value is actually a proportion, so there will be a 95% CI of the proportion as well. So this is actually the standardized writing method when you are about to write on the confidence interval. So you need to write it this way. We are 95% confident that the prevalence of stroke patients admitted to HRPZ2 ranges between one value to another value. Okay, so this is actually the formula for single proportion. Commonly in social sciences, we use 95% CI, Z-score 1.96. The p-value, you can calculate yourself from database, or you can get the information from any journals who already had conducted the study in among the stroke population. And then again, for precision, you need to ask the expert guest, okay? Not simply by yourself, but you can discuss this. Okay, this is the example given you here. So information, because I collect data when I was in Kelantan. I did my PhD in USM Kubang Krian. So this is actually the database from Malaysia Department of Statistics about the populations of Kelantanis between 35 to 65 years old. So why I choose 35 to 65 years old? Based on epidemiological findings in that particular year, because I did my study in 2011, few years back ago. All right. So few years back ago, it mentioned that among this group, 35 to 65, stroke is commonly happen. So the estimation, it says that approximately 52,000 of population suffered from stroke annually. You can also use this percentage and turn it into proportion, doesn't matter. But in my case, I wish to estimate according to my to infer to my parameter later on. So I estimate I calculate the proportion based on this information. 52,000 people suffered stroke annually in a year, and divided it into accordingly to the category of patients. The population of Kelantan 35 to 65 at the moment, and I've got the P 0.12. So after that, when I've got the informations of the P of 0.12, I insert into the formula n equals to 1.96 over 0.005. Then I times with 0.12. Then 1 minus 0.12 equals to 162. So consider about the attrition or dropout rate, the range might be between 10 to 20%. So the required samples will be 178 samples. Okay, so this is actually the example how you can use the single proportion formula, the Z over precision, and then you times proportion and 1 minus the proportion. So this is one type of single proportion formula for you to calculate the prevalence. Okay, the sample size required for a prevalence study. Okay, this is another example as well, adopted from Prof. Hatim research book. Okay, I give an example. A hospital stroke unit wishes to estimate the prevalence rate of stroke occurrence among adults between 35 to 65 years old in its locality. So how many stroke patients should be included in the sample so that the rate may be estimated to within 5% percentage points of the true value with 95% CI. So 5% is actually the precision. So you turn it into a proportion. So you insert in the same formula I showed just now. So 1.96 over 0.05. Then you multiply with the proportion 1 minus 0.2. So it turns out the required sample is 246, but don't forget you need to add 10 to 20% attrition. Okay, so again, you need to discuss this limitation for data collection with your supervisor. Are you really able to collect data among 246 plus another 10 to 20% attrition between certain period of time? So large number sample size usually will need more time to complete the study. Do you have the money or capitals to conduct the survey, and you able to manage your data by yourself? So this is the things that you need to consider for your study. Okay, could we have like a 5 minutes break before we proceed to the example of 3 and 4? Okay, now it's 9:53. Okay, for your information students, I'll be having a visit later on at the kuliah. So if the visitor have arrived, I have to stop the session and I will continue after that. But don't worry, I have quiz prepared for you, and I will just share the slide later on with you guys. So we have 5 minutes break. We'll come back at 10 a.m. Okay. Okay, welcome back. Uh, Name two types. So my question for you before we proceed to the example for objective number 3 and 4. So name two types of sample size formula for estimation. Okay. What would be your answer? Just type in the chat box. If you wish to estimate the prevalence, what would be the sample size, the name of the sample size formula? Okay, I look forward for more answer. Right, good. Hey, anyone? All right, good try, Sister Amira. Okay, shall we proceed? Oh, before I forget, let me share with you the sample size calculator. Um, this is actually developed by Dr. Wan Arifin from USM Kubang Korean. When I was a student, I still remember that he just mentioned that whoever has these exercise, feel free to share with other people. So ini kind of kita cakap saham akhirat seseorang jugalah sebenarnya. Okay. Alright. So you can utilize this later on when you are about to perform the sample size calculation for your study. Okay, now let us proceed with the objective number 3, number 4. Okay, hold on Let me share my screen. Okay, alright. Okay, now we come to the example for number 3 to compare the mean of carbohydrate intake among stroke patients admitted to HRPZ2 in intervention and control group. Okay, now the keyword here. Okay, any one of you feel free to open up the mic. The output here, what types of output? Is it a numerical data or is it a categorical data based on this statement? Anyone? Buka je mic. Jangan malu.
Numerical data.
Yes, exactly. It is a numerical data. The output is in the form of numerical y to compare the mean. Okay, now, what is the independent variable in this statement? Any one of you? What is the independent variable from this statement? So anyone, you wish to try? Sebab I tak nampak you all I hope that you could open up your mic and you just mention what is the IV here. What do you think is the IV?
The amount of carbohydrate intake.
That is the outcome. That is the DV, the mean of carbohydrate. So from this statement, perhaps what is the independent variable here from the statement to compare the mean of carbohydrate intake among stroke patients admitted to HRPZ2 in intervention and control group? Any one of you? Your answer, the first answer is correct for DV. The outcome is the mean of carbohydrate. So in this case, what is the independent variable? Siapa nak try?
Doctor, is it the stroke?
Correct. The group is the IV. What do you mean the group? Which one?
The stroke group and the control.
The intervention and the control group. Correct. Okay. Congrats for both of you who attempted to answer the questions. Okay, so this is very important. When you look at a statement, you need to find what is the IV, what is the DV, and what is the nature of the DV. Is it numerical or is it categorical data? Therefore, why we choose t-test formula? Because we can see clearly the IV it is actually referring to the intervention group and the control group. Therefore, we need to pick t-test formula when you are using PS software. Okay, I hope that any one of you, if you have no PS software yet, okay, let's we go together. Go to the you can just type at the Google PS software. It is actually available online. Sample size calculation. Alright. Okay. Then you can click here. PS Power and Sample Size software and download it. You can try it now. Yeah, it is free download. Make sure this is the logo. You have the same logo like mine. Okay, you try to download the PS software now. Okay, lucky enough, the delegates that will be visiting my kuliah is still on the way at the middle of the highway. So we can just continue with our class. Okay, make sure you try to download the software first. Okay, I give you some times so that you can download the software. Okay, I will open up mine because I have it already. So make sure you get the software installed in your computer. So at least you get to know another types of software available for sample size. Alright. I give you like 5 minutes to try to get this software and install in your laptop. Okay. Did you guys manage to install the software? Okay. Stop sharing first. Okay, please say yes once you install. Okay. Okay, great. Yeah, I need to see more numbers who managed to install. So that I will wait for all of you to manage to install, then I proceed with the example so that you can have time to explore. Right. For those who just come in, please explore PS software and install it into your laptop. I can't, Husna. You can't. Perhaps you need to double check about your pop-up blocker. Just in case the pop-up blocker is turning on, it might hinder the process of downloading the software. So just double check about your pop-up blocker then. Okay, just give a try to install. I give you like another few minutes before we proceed. Okay. All right. So just now, we already learned several types of formula that you could apply using the estimation, sample size for estimation. And now we come to the stage of understanding different types of software that you could apply to calculate the sample size for hypothesis testing. So the example that I've given earlier to compare the mean of carbohydrate intake among stroke patients admitted to HRPZ2 in intervention and control group. Here, the DV is the mean of carbohydrate and the IV is the intervention and control group. Therefore, we will be using the PS software and we'll be applying the t-test formula. All right. So this is the scenario. Okay, you are about to conduct a study among stroke patients to determine the difference in mean of carbohydrate in 3 months between the control and intervention group. So you need to set the parameter. So type 1 error 0.05, two-sided group. You set the power as 80% in the form of proportion. The detectable difference is 1.5. Why? You, as a researcher, you expect the mean difference of carbohydrate intake in a month different between the 3 months different between the control and intervention group is minimum 1.5. You can actually manipulate this whether if you're confident to put 2, 3 and that one is actually up to you. So in my case, I wish the ratio between the stroke patients in my control and intervention group is 1, or either you might have an intervention group 1 or the control group twice higher or twice higher in the intervention group. Either way, so in my case, my sample in the control and intervention group is equal, so I put it as 1. Alright, so once you enter into the software, so go to t-test. Okay, let us do it together. Okay, so whoever managed to download the software, you look at here first so that you understand how to navigate the PS software later on. So you go and choose t-test and then make sure at the drop down button you choose sample size and whether the design is paired or independent. Remember, we have independent. At our statement, it is clearly mentioned we have the control group, we have the intervention group, so that is independent. Okay, don't forget to enter the details. The alpha is 0.05, the power is 0.080, so the uh, difference is 1.5. This one, you need to get the mean from the paper. So I put it as 1.9. And then the ratio between the control and intervention group is equals 1. Okay, and then you calculate and you will get the sample size because the nature of my study is actually an intervention study. So you can see here, automatically, what is the best things about PS software is that it helps you to give the interpretations of the sample size calculation and you can just crop this answer and put it in your thesis. So it would look this way. This is the words. So it needed to be noted that at this juncture that there was no intervention study that had been carried out. And why I did the study. So from where I got the standard deviation, so the information I've got the standard deviation. Sorry, that is not mean. There is a standard deviation 1.9 from Pang et al. So if the true difference in the experimental and control means was 1.5, 26 experimental subjects and 26 control subjects were required to reject null hypothesis. So this is actually the statement come up from the PS software. So this is the best thing about PS software. You don't have to crack your head to write a statistical types of statement. It will do for you. Okay, now let us go together with the software manipulation. All right, come. Okay, so whoever managed to install the software, just in case we might forgot the details here. Okay, so go to t-test. Okay, let's do together. Select sample size. Okay, and then choose independent, and this will give you the information. You just can click here. So alpha, the type 1 error probability for two-sided. So normally for two-sided, you put 0.05, and then N for independent is the sample size. The power for this one, normally we put 0.08. So this one is the difference, delta, and this is the standard deviation, SD, and then M is the ratio between the control to experimental subject. So it helps you with the information. If you sometimes you might forgot what the symbols referring to, just like what I've been experiencing just now. Okay, so this helps you to inform you about the details of the symbols. Okay, so 0.05 you enter there at the alpha, then 0.80, and here is 1.5, and then you put 1.9. The difference is 1. Then you can calculate. So if you see here the description, so the one that I'm actually extracting and write into my thesis is the description that's come out from the PS software. Okay, if I go too fast and you wish me to repeat, kindly let me know. Alright, you guys managed to do together with me? Boleh ke? Are you okay, guys? Alright, great. Okay, do you want me to repeat? It's okay, I can proceed with the next step. Okay, great. That you guys managed to follow my steps. Alright, okay, now we go to the example number 4. Okay. Okay, there's actually a lot of formula in regards to sample size calculations. So whatever I'm teaching you is actually a very small part of it. Alright, so go out there and explore. And of course, you need to consult your supervisor. You need to consult proper statisticians for this case. Alright, so we come to the another example to compare the proportions of obesity among male and female athletes. Alright, again, okay, may I know what is the outcome here? What is the DV here? So anyone wish to try? What is the DV here? What is the dependent variable based on the proportion? I can't see you, so I hope that you can just turn on your mic and answer it.
Proportion of obesity is the
Yes,
dependent
correct.
variable. Yeah.
Yes, proportion. So what about the IV here?
Gender,
Yes,
male
gender.
and female.
Yes. Okay, therefore, the same technique, we can, because our outcome here is proportion. Proportion means percentage, and it is in the form of a categorical data. So we cannot use the t-test formula because t-test formula is meant for testing to get the sample size to calculate the sample size for a numerical outcome. So we need to use the dichotomous formula in this case. Okay, so based on the scenario, so you are about to conduct a study among stroke patients to determine the difference in proportion. Remember here, proportion of working methods between the control and intervention group. Okay, the set value would be 0.05. It will be two-sided. You set the power as 80%. The detectable difference is 10%. Okay, determination of detectable difference must be determined by researcher. So not from previous study. You can decide by yourself. So one of the proportion, either from exposed group or control group, should be obtained from previous study. Through the previous figure, the researcher could estimate the proportion of increment or decrement of the value, and the value become the detectable difference. So in this case, I'm assuming the difference will be 10% higher. And similarly, in this case, I put 1 because the number of stroke patients in my study will be equal number of stroke patients in the control and intervention group. Okay, so how are you going to choose the appropriate statistical test? Is that the formula? You choose the dichotomous, so you calculate the sample size. So remember, the outcome is in the form of categorical data. Therefore, you need to use the chi-square. So you fill up the parameters, you calculate it, and ratio, of course, is not fixed. Common rule of thumb, intervention more than the control. Most of the time, the intervention will be more than the control. Okay, and then here, remember, because we have two groups and the nature of our study is a categorical data, so you cannot use t-test, you must use dichotomous. Then make sure it is sample size, you choose independent, you choose prospective, and you need to choose two proportions because you are comparing the gender, male and female. And make sure you check uncorrected chi-square over here. So I put 0.05 here, 0.8. If you remember, the difference is 10% higher. So my baseline group, the control group, is 0.27. And the intervention group is 0.37. And M, the control group, and the intervention group is 1. Then you calculate the sample size. So after you calculating, it will give you the analysis will inform you the descriptions that you can crop and put into your thesis. Okay, let us do the exercise together. All right. Okay, open up your PS software. This time around, you need to choose dichotomous. Make sure you click sample size. Remember, it is an independent group because we have the female, we have the male, and then it is a prospective cohort. In my case, because I am doing an intervention study, so it is a longitudinal nature or observational. And I choose prospective instead because there is no observational here. The choice is either case control or prospective. Even if you're doing survey, you put it prospective. Okay? Alright, so what are you going to choose here is a proportion because two proportions because you are comparing the difference between the male and female. And then make sure you choose chi-square, uncorrected chi-square, because the nature of our DV, it is in the form of categorical data. So you put 0.05 at the alpha, then you put 80%. Remember, this is some things that you get from the previous research. And remember, I estimate the percentage would be 10% higher, and ratio between the control and intervention group is equals to 1, and then we calculate it. So the sample size that required in my study would be around 340. So I hope that all of you managed to get similar number with me. All right. Okay. Are you guys okay? All right. So remember, PO is the control group, P1 is the intervention group. Okay. Right now, we proceed to the method of calculating the sample size manually using two proportion. Okay, we have this formula. So remember, you can, of course, if you ask me whether I memorized this formula, no, I didn't memorize. So whenever I am about to prepare a proposal, even for grant or even for teaching you guys, I always bring back all my notes. So you can see how my notes is actually on my table right now. All the books are still referring back to my alma mater reference. Okay. So N, of course, is the required sample size, alpha. Level of statistical significance, 1 minus beta is the power of study. So Z alpha is the value of the standard normal distribution, cutting off probability alpha in one tail. For one-sided, normally, okay, for social sciences, most of the time, we are using the two-tail. Because our study is not kind of really need a good precision. However, for those from Korea or pharmacy, if you're testing an efficacy of a drug, I would say that you might having the one tail. Okay, for us, our power at 80% is already accepted. But for you guys who are actually doing on efficacy drug testing, it might be higher, like 95 or 99%. It must be 90 and above, definitely, because if you're producing a drug, definitely from 100 of patients who testing it, only one die, then you can be, the drug is safe. So if you are testing the drugs on 100 participants, 10% die, of course, you don't want to take that drug, right? So I will say that the power will be different for those who did study on drug efficacy. Okay, for those social sciences who just collected survey among the respondents that doesn't related to something with life, I would say that the power could be lesser. Okay, so remember the Z alpha 1.96 for alpha 0.05. If one tail, the precisions like I mentioned, the drugs, you're about to testing the efficacy of certain new drugs on certain on humans after the in vivo study. So one tail will be used 2.5. In that case, your date value will be 2.58. So for Z beta, 0.84 for the 80% or value of the standard normal distribution cutting off probability beta. So ZB here, the 0.84 for 80%. For 90%, you need to put 1.28. So this is a guideline. Okay, so you can just enter the data into this formula later on. So this is a two proportion formula. Okay, and then I give you the example here just now. Okay, two population male and female athletes differing in exposure to a particular lifestyle, which is believed to be associated with obesity. I still remember. I was reading the one article, and I've got the idea for the scenario from that article. So there is a need to understand this issue for necessary weight management intervention program. So the prevalence of obesity among male control is 0.27. Meanwhile, the prevalence of obesity among female control is 0.37. So how many athletes do we need for the program if the power of study is 80% with the significance level of 5%? So remember 0.27, 0.37. So you insert in the formula. So you need to, first of all, please come up, you extract the information. So PO referring to the control group, P1 is referring to the intervention group, and you put into the formula. And remember the formula earlier just now, the P1, 1 minus P1 plus P2, 1 minus P2, then over P1 minus P2, apa ni, kuasa 2 in English, I forgot lah. Okay, that's what I'm trying to mention here. So then you follow the formula and you start doing the calculation. Alright, then you get 337 as overall sample size needed. Okay, so we come to the last slide. So in order for you to determine the appropriate sample size calculation, you need to consider appropriate research design. You need to clear the requirement, the informations that you have in your RO or your RQ and RH, because after you know what is your outcome, the dependent variable, the independent variable, a little bit information on the research design, then it is important for you to select the correct type of sample size calculation. So as I mentioned earlier, we have two types of sample size calculation. You can use the manual calculation or you can use the software calculation. So for today, I'm introducing you guys with PS software. There are many software out there like EpiInfo, G-Power. So just explore, select the one that you think suits you and you are familiar with and it's easily for you to interpret. The thing is that you need to interpret. So choose the one that you are familiar with. So again, you need to refer the information, for example, the mean, the proportion, the detectable difference, all these things is actually you need to refer back to the previous publications or the availability of population sources or database. Alright, so some part of this lecture, I'm referring to the slide from my friends, Madam Wan Shakira Rosette. Oh, she is no longer with IPH. She's now in nursing division. And following the notes also, is actually I obtained from my alma mater, from Dr. Syed Hatim. Okay, so the software I share with you is actually from Dr. Wanur Arifin. The PS software, you can also navigate from here. And yeah, the software here, Raosoft. This is also valuable if you're doing survey. And these are the references that I've been using for today's presentation. Okay, guys, do you have any question to ask me so far? Boleh faham ke? I hope I didn't go too fast today. Sebab normally orang cakap, I cakap laju. Boleh eh? So, I will share the slide. Okay, I believe there will be a break session after this. We will come back at 10:45. Alright. Okay, so bear in mind I will be playing quiz after this and I will give you some exercise that you can take home and try. And if you need to get the answer, we can discuss it. I give you time to try to hands on and we try to get back into the discussion maybe around 12. However, if my visitors already arrived at faculty, I will leave the answer in the chat box. As long as you get the answer correctly, then that is actually you are doing right. Okay, so I will share my slide here. Try to come back for practical session. It's just a short quiz, just to test you how much you are ready. Only you know your marks, okay? Not to worry. Okay, I will share my slide after this, yeah? Alright, see you around, we follow the tentative 10:45 for practical session. Okay, thank you.
Thank you, Doctor.
Okay, welcome. Mm-mm.